Alright, so we're going to start with number 7, where you've got this kid on a swing, and they want to know the centripetal acceleration at the bottom of the swing, and what provides the centripetal force that keeps the child moving in the dark. So, technically the force is mentioned, and that's why you would need a force diagram in your picture. Alright, so let's start by the fact that the number 7, the child is moving in a circle. Therefore, must accelerate towards the center. I'd also probably put in there, to show I understand it, the faster and or smaller radius the more acceleration. So if you move in a smaller circle or you travel faster, you're going to have more acceleration. And that's just because the lazy drawing. We'll just grab this picture. It is. And my force diagram, let's see. There would be weight down. There would be tension upwards. And the child would be accelerating upwards. So that's what you would need for your force diagram, which right away leads you to the correct answer for part B, because the force that provides that centripetal acceleration has to be pointing in the direction of it. Guys, remember, you don't have to do the props like you're not, but you need to be quiet enough that I can hear myself, and when I'm recording, we're not catching you guys messing around, but we're catching what I'm doing. Yes. So please, just sit there. I know it's your last day. Just sit there and do something, or do these problems, because they do go on your term. Great. All right. So thank you. So back to what we're doing. The only force that's pointing in towards the center of the circle as it swings is that tensional force. So when they're back here and they're asking what provides centripetal force, it's got to be the one that's pointing in the direction of the center of the circle, which is the only one is the tension in the rope. All right. So now we need to do part A, which is what's the centripetal acceleration of the child. So start off with our physics equation, v squared over r, and we're given v, and we're given r, I believe. We're told the r is 8.1 meters, and the speed at the bottom is 8.4 meters per second. So substituting in those, 8.40 meters per second over 8.10 meters, and do the math, and I'll come up with an answer in meters per second squared, which is, I think, the units that they wanted. Yeah. All right. Most common math mistake will be to forget to square that top number. Oh, you've come to collector? Very nice. All right, so we're going to do number 5. What is the minimum speed a roller coaster can be traveling when upside down at the top of the circle so the passengers will not fall out? Now, this is one where technically you didn't need a force diagram. So I'm going to do it without one, but you could just easily have one in here. It's number 5. And what they mean by not fall out, it means that they're not going to leave the circular path. So, what do you not, if you were just suspended up there at the top, why would you fall down? Because gravity causes you to accelerate downwards, right? To stay in the circular path, you have to accelerate towards the center of the circle, which is downwards when you're up at the top, right? So if the acceleration needed to keep you in the circle is the same as what gravity is providing, then you're going to stay in the circle. If gravity provides more acceleration than you need to stay in the circle, you're going to fall down out of the circle. If it provides less, then you'll just need another force to provide more acceleration, say the seat against you or something like that. It's kind of like, you know, you have the ball on the string, we whirl around a little bit. Or, and if I go too slow, it falls out of the circle at the top because it's accelerating down due to gravity. If I go just the right speed, it just makes it without using any tension in the cord. If I go faster, I've got to have that tension in the cord. Alright? So they're looking for that point where you're going just fast enough you don't need the tension. So, I'm going to say that gravity will provide the acceleration towards the center of the circle. And so, that's going to be at the top that we'll start with our, they want to know, let's see, they want to know what's the minimum speed. So I should use the form of my centrifugal acceleration that has speed. They give me the radius, so I'm going to use AC as v squared over r. The AC, if gravity is going to provide it, should be equal to little g, v squared, and then my r is, for me, is 8.2. So we can also, for g, put in 9.80 meters per second squared. And then you have one equation, the only variable you're left with is v. Most common math mistake will be forgetting to square root your answer. You'll get an answer for v squared, and you'll put that in rather than doing the square root and finding v. So be careful of that.